Okay, today I'm going to discuss how to solve integrals by using trigonometric substitutions. This table here summarizes the cases in which you can use trigonometric substitution. It says here that if your integrand consists of this form, okay, square root of a squared minus x squared, square root of a squared plus x squared, and square root of x squared minus a squared, then you use this substitution, okay, to make your evaluation of the integral easier and simpler. Okay. So in other words, those integrals for which the integrand has these expressions or has this form are those integrals that we can solve using trigonometric substitution, except when the derivative of this is present, no? Kasi we can just use integral of u to the n du in that case. Okay, so to discuss how to solve integrals using trigonometric substitution, let's try the following examples. Okay, and let's start with number 1. Okay, this is our example number 1. What is the integral of dx over x squared times square root of 4 minus x squared? Okay, you notice this form, square root of 4 minus x squared. From our table, this is that form, no? Square root of a squared minus x squared. So the substitution is x equals a sine theta, where your theta is restricted between negative pi over 2 and pi over 2. Okay, but actually, even without the table of trigonometric substitution, you can also derive the trigonometric substitution by in this triangle, okay, right triangle, where this is your theta, okay, you have this form, right? Okay, obviously square root of 4 minus x squared is the result of using Pythagorean theorem, where 4 here is the square of your hypotenuse, meaning your hypotenuse is 2, and this is either this leg or this leg of the right triangle. We choose to write x here. Okay, and although you can also put this x here, but in that case you're going to use a different substitution. It would be x equals cosine. To be consistent with what's in our table, let's put x here. Okay, so using Pythagorean theorem, this will be square root of 4 minus x squared, right? Okay, and then from this, your x is, remember, you have opposite over hypotenuse, no? Is your sine. So sine theta is opposite over hypotenuse, and opposite is x, and you can express x in terms of 2 and sine, so that would be x equals 2 sine theta. Okay, so this is our trigonometric substitution. Okay, later when you do your solution, you can just directly refer to the table without this one. Okay, but it's nice to have this one because this will serve also as your guide later, especially in expressing your final answer in terms of x. Okay, so if this is your x, then your dx should be 2 cosine theta d theta. Okay, now we want So we are able to find for an expression for dx and x, but we don't have the expression for square root of 4 minus x squared. Although you can substitute it directly there, and as you go on with your solving, you can find an expression for this. But let's do it here. Okay, what is an expression for 4 minus x squared? Okay, we can write that as 4 minus, we know that x is 2 sine theta, so the square of that is 4 sine squared theta. Now 4 is a common factor, and square root of that is 2, so we can put that outside, and you have square root of 1 minus sine squared theta. Now the identity related to this is, what is square root of, what is 1 minus sine squared theta? Remember, from trigonometric identity, you have sine squared theta plus cosine squared theta is equal to 1. So that means that your cosine squared theta is actually 1 minus sine squared theta. So this is cosine squared theta. And the square root of that is cosine theta. So that's it. We can now express. Let's go back to our problem. Let's express this now using trigonometric substitution. You have integral of, what is your dx? Your dx is 2 cosine theta. 2 cosine theta d theta, then over x squared. Now your x squared is 2 sine theta squared. Okay. Times square root of 4 minus x squared, which is 2 cosine theta. Okay. 2 cosine theta. So simplifying, we have integral. This will cancel. Okay. So you're left with d theta over 4 sine squared theta, which is equal now to, we can write 1/4 outside. Then you have integral of, look at this, what is 1 over sine squared theta? 1 over sine squared theta is actually cosecant squared theta, right? D theta. And then the integral of this is, you have 1/4 cosine squared theta. Integral cosine squared theta is negative cotangent theta plus c, which is equal to negative 1/4 cotangent theta plus c. Okay, take note that you have to express your answer in terms of x. So that means that cotangent theta must be expressed into an expression in terms of x. How do we do that? Well, we know that cotangent theta is cosine theta over sine theta, right? And cosine theta from our substitution here is cosine theta is square root of 4 minus x squared over 2. Okay, square root of 4 minus x squared over 2. No question about that, right? Okay, just divide both sides by 2, then you have cosine theta over squared times is equal to square root of 4 minus x squared over 2. Then what about sine theta? Sine theta is here. That's x equals 2 sine theta. So that means that your sine theta is x over 2. So you have x over 2. So we cancel that. So our final answer would be negative square root of 4 minus x squared over x plus c. So this is the integral of dx over x squared times square root of 4 minus x squared.